Hello, greetings. In this video, we shall see how websites leverage transport layer security, also called TLS, to keep our data safe during data transit. This means that the data which is passing from client to server and from server to client is encrypted and hence is much more secure. Let's get started. Let's start with some of the key concepts of what exactly is leveraged in TLS. So TLS leverages a combination of symmetric and asymmetric cryptography. And why it uses both the cryptography is because there is a trade-off between performance and security when transmitting data securely. Asymmetric cryptography is much more safe, but at the same time, performance-wise, symmetric cryptography is much more better. So thereby, we arrive at symmetric cryptography leveraging the asymmetric cryptography. We shall see the details and it shall become much more clear. Now, symmetric cryptography, as you may be knowing, is when we encrypt and decrypt the data using a secret key which is known to both sender and recipient, meaning there is a key which is shared between client and server, and if in case the key is leaked, then the data safety is at danger, at risk. So this is performance efficient but is prone to security issue if the key is leaked. Asymmetric cryptography uses key pairs, which means a public key and a private key. Data is encrypted using public key, and as the name says public key, this public key is available to everybody. Data is decrypted by the private key, and private key is only available to the recipient. So the server, the recipient would be having a private key and thereby would be able to decrypt the data which was encrypted using a public key. Process of sharing the key does not have to be secure because even if the public key is known to public, there is no danger, and the private key is retained by the server or the recipient. So sharing the key does not have to be secure. So TLS uses asymmetric cryptography for securely generating and exchanging a session key. So now we can see that TLS uses asymmetric cryptography for securely generating and exchanging a session key. This session key is basically the symmetric key which shall be used. The session key is then used for encrypting the data transmitted by one party and decrypted at the data receiving at the other end. Once the session is over, the session key is discarded. Client connecting with server should validate the ownership of server's public key. So this is very important that the public key which is sent by the server should be validated, and how it is validated is using the digital certificates which are signed by something called as a CA, certificate authority, and the CA verifies that the certificate and the public key are valid and belong to the said server. Thereby the public key is safe and secure, and it is verified also that it belongs to the server. Now let's see the various steps which are there. The first step is that the client would be sending something called as a client hello along with supported cryptographic algorithms, the TLS version it supports. Post this, the server returns with something called as a server hello. And again, it will share the cryptographic algorithms and the TLS version it supports. Post this, server sends its certificate, which is basically the public key which we were just referring to. So the public key is available with the client now, and thereby after having the public key, the client and server arrive at something called as a session key, which is a symmetric key. This symmetric key or the session key is finalized, and from now on, this is the key which shall be used for transferring any data. The last step is where this symmetric key is used for encrypting the data. And now, because the data is encrypted, even anybody in the middle, the man in the middle kind of attack, even if they get the data, they won't be able to decrypt and read the data. So it's a garble or a garbage for them, and thereby the data in transit is much more secure. Now, this is a summary. Whatever we discuss, let's summarize it quickly. How TLS prevents data in transit and man in the middle attacks. So encryption, we saw it already. TLS uses encryption to protect the data exchange between client and server. So even if the data is intercepted, it is unreadable without the decryption key. So, and the decryption key is not available, thereby the data is, even if it is intercepted, it is safe. authentication, we saw that TLS uses digital certificates to authenticate the identity, and TLS certificates are trusted because they are validated by the CA, Certificate Authority. Key exchange. So TLS uses secure key exchange mechanism to establish shared secret key between client and server. Okay, this is what is called session key. Integrity checks. So this we had not seen in detail, but what happens is that we set a cryptographic hash along with the data, and this hash verifies that the data which is sent is not modified or not updated in transit, because the hash of our data would always be the same. So from the data you can always generate the hash. From the hash you cannot generate the data back. If the data has been tampered with, the hashes won't match, indicating a potential man in the middle attack. So, which means if the data is modified and the cryptographic hash is not matching with the data, that would clearly indicate that the data has been modified and integrity check will fail. Thereby, the client will reject the data or the server will reject the data. The last thing is perfect forward secrecy. Let me give you the example. So this is user one. It did some session, it arrived at a session key and it completed its work. Now whatever it was doing, the data in and outflow of this data, this was interrupted by a user called, uh, let's say the user was a attacker A1. So A1 has access to all the data which was done between these and these, but the session key he does not have, so he cannot decrypt the data. Now let's say he A1 has another is a valid user and can able to log into the site, and now he has his own session key. Now if he has its own session key and he tries to use that session key to decrypt the existing data which he got from this session, so this was session 1 and this is session 2. So whatever he got from the session 1, that data with the session key of the session 2, if he tries to decrypt, that would not work. And that is what is perfect forward secrecy. TLS supports perfect forward secrecy, which means that even if the attacker manages to obtain the private key in the future, they won't be able to decrypt the past communication. This is because a new unique session key is generated for each session, and compromising one key does not compromise the security of other sessions. Okay, so this is what I wanted to present. Thank you very much.